Hey maths fans, relations and functions is the topic here. What we're going to be covering, we're going to be saying what is a relation, then we're going to see what a domain and range, then we'll see what a function is, and then we'll try and decide if we have a relation or a function, how to tell the difference. So a relation is pretty much what it says. It's a relationship between values. Probably a very common relation you might see is between x and y values in coordinates or ordered pairs. Now, you'll see this language here of ordered pairs. As far as I'm aware, the most common ordered pairs you see are coordinates. But I looked this up and I got a very good definition. So I'm just going to take a little digression into what ordered pairs are and the difference between coordinates and ordered pairs. Well, 7, 2 there is an example of an ordered pair. It's also an example of a coordinate. What is the difference? Well, an ordered pair is any pair of numbers, usually put in those brackets and separated by a comma, and it's where the order makes a difference. So, for example, A then B is not the same as B then A. We're giving you them in a set order. Like coordinates, we have an x and then a y. Now, they might be coordinates, but they might also be some other inputs and outputs that are in the right order. For example, here, if we had this ordered pair, that input might be an age, and the output might be an income at that age. So, they're very closely linked. Coordinates are ordered pairs, and most of the time, if you see ordered pairs, they will often be talking about coordinates. Just to sum up though, 2, 7 is not the same as 7, 2. You can see on this coordinate grid, the order makes a difference. That's why they're called ordered pairs. Anyway, that shot a little bit off topic, but important to understand if we're going to be able to look at relations and functions. So, we've got a relationship between two values. For the most part, we're going to assume those are coordinates, x and y. And we often express a relation in the form of an equation. So, for example, y equals x plus 3 is an equation of a relation between x and y. So a relation is just a relationship. Pretty straightforward so far. Let's talk about domain and range now. So, important to get these in the right order. So the set of all of the inputs, and if we're dealing with x and y coordinates, that's going to be the x values. That's called the domain. So the inputs, the things that go in, is the domain. And the things that come out, the outputs, are the range. So generally, if we're talking about x values and y values, x values are going to be the domain, the things we put into our equations usually, and the outputs are the y values. That's called the range. So domain, inputs, outputs, range. Get them somehow noted down, get it stuck in your brain. Let's look at some ordered pairs here. So if we have some coordinates, 1, 4, 2, 5, 3, 6, 4, 7, the domain of those are the x values, the inputs. And the range of those are the y values, the outputs. Okay? Domain and range. Pretty straightforward. Just remember which one's which. Going on then, let's have a look at a function. Now it's going to get a little bit more confusing, I guess. It'll be some familiar simple maths, but being able to spot what makes a function starts to get a little bit more complicated. So, a function is a relation in which each input has exactly one output. Now, most kind of simple operations that we can put on an input are going to be functions. For example, multiply by 2, add 3, subtract 5. They're all going to be functions. They are relations that are also functions. Let's do a very simple example there. If I had the function to add 3, each input, 2, add 3, is 5. It can't be anything else. It has one output only. If I put in the number 7, it's 10. It can't be anything else. If I'm adding 3 to it, there's one output. It's probably easiest to describe what makes a function by giving you something that is not. So here is a non-example. Square rooting is not going to be a function. So if I input 25, the square root of 25 is 5, and it could also be -5, because minus 5 squared is 25. So to square root, that is not a function, because there are two possible outputs. We have different options on the output. This is called a one-to-many relation. Here we have a one-to-one relation because every individual input has a single output. This one we have one-to-many, and that's not a function. If there are many outputs for the same input, not a function. Let's look at that in a sort of diagram here. So when we have one-to-one, here we have a very simple relationship. The output is 2 more than the input. If we call them x and y, then you've got y equals x plus 2 in that one. Here we have many different inputs for only one output for each input. So we could have that there are many different ways of getting the 4. So in this case, I think what's happening is we're doing y equals x squared. And minus 2 squared gives me 4. This is still a function because each individual input only has one output. 0, I enter it, I always get 0. 1, I enter it, I always get 1. 2, I enter it, I always get 4. It doesn't matter that there are other ways of getting 4, as long as there is exactly one output for each input. Try and get your head around that language. These are not functions. This is the square rooting function. So we're saying y equals the square root of x, perhaps. Well, 1, the square root of 1 is 1. 9, the square root is 3 or -3. And actually, this isn't that function because we would have to have 2 different outputs for that function. So this is some other sort of relation, not function. So also many to many. If there is the 3 could go to a 5, the 3 could go to a 6, that is not a function. So let's go back to that very basic definition. A function is a relation where each input has only one output. Okay? Let's look at some examples. This hopefully will help us to get our heads around this. So, let's have a look at A. Is this set of ordered pairs a function? Well, 1 goes to 5, 2 goes to 10, 3 goes to 15, and 4 goes to 20. Each input has one output. 1 has 5, 2 has 10. Yes, that is a function. Because each input had one output. Here, each input, 1 has 5, 2 has 7, 2 could also be 9. Well, has each input got exactly one output? No. The input of 2 goes to 7 and 9. This is not a function. And 3 goes to 11. We've already decided it's not. On here, 1 input, we get 5. 2 input, we get 5. That's not a problem so far. 1 input, we get 9. Now we can say this is not a function. Because for the input 1, there were 2 different outputs. So that is not a function. Another example here, we've got 1 input to get 100, 2 input to get 100, 3 input to get 100. But that's okay, because those inputs are all different. Having the same output is not the problem. The problem is when we have the input giving different outputs. So this is a function. So what we're looking for is when we see the same input having a different output. Same input, different output. That's a problem, that's not a function. Try these. Here is some sets of ordered pairs. Decide if they are functions or not. I'd pause it now, have a go at these, and then I will move on. So, hopefully you've paused it, hopefully you've had a go. If you haven't, pause it now. Here's some answers. The first one, is this a function? 1 to 5, 2 to 7, 3 to 9, 4 to 11, no problem, function. No two inputs had no two of the same input had different outputs. 5, 5, 7, 7, 9, 9, 11, 11. Yeah, it's okay if the input is the same as the output. That is a function. 1 to 5, 1 to 7, 1 to 9, 1 to 11. Not a function because we don't have exactly one output for the same input. Then D, 1 goes to 5, 2 goes to 5, 3 goes to 5, 4 goes to 5. Well, that's fine. Yes, that's a function. Because we don't have the same input having different outputs. We've got the same output for different inputs, but that's okay. Then the last one, 1 goes to 5, 2 goes to 5, 3 goes to 5, and 3 goes to 10. This first 3 is not a problem, but here the 3 could be 5, the 3 can be 10. That is not a function. So there we go. We've tested whether sets of ordered pairs are functions or not functions, and we'll be looking at some graphical examples in the next video. Thanks for watching.